All right, so I'm going to get us started on completing one of these charts dealing with LeChatelier's principle. So in the first column, we're going to write whether the change is going to cause a shift to the left towards the reactant side or a shift to the right towards the product side. We're going to write this in order to indicate how the system will reestablish equilibrium after the stress is applied. Then, in terms of concentrations, we need to write whether or not the concentration will increase, decrease, or stay the same. And we also will need to apply that to heat because we know heat can be viewed as a reactant or a product depending on the situation. In the column that is labeled temperature, you can write increase, decrease, or no change as well, and you can use that to represent your heat. Notice that when we write increase, decrease, or no change, that is to represent what will happen to those particular molecules after equilibrium has been re-established. So let's assume everything's at equilibrium. By adding H2, I am adding one of my reactants to a system already at equilibrium. That stress results in more collisions between H2 and Br2, my reactants. More successful collisions with my reactants increases my forward rate, which means I will shift to the right. By shifting to the right, if I am going to react particles of H2 and Br2 together, their concentrations will decrease in order to form more products, such as HBr, which will increase. Heat is also viewed as a product, so that means this is an exothermic reaction, so the temperature will also increase. If I apply the same idea to adding HBr, HBr is a product in this scenario. Adding HBr increases collisions between my product molecules. This increases the reverse rate of reaction, which means we're shifting left. So to summarize, shifting right means an increase in the forward reaction. Shifting left is an increase in the reverse reaction. If we're increasing the number of collisions between HBr molecules, that means their overall concentration will decrease because they will be forming Br2 molecules and H2 molecules. Since HBr is reacting, that means the temperature must also decrease because that temperature is viewed as a product. Go ahead and complete this chart along with the chart below it using the same method. Some things to remind you when it comes to pressure is that you will have to pay attention to the total number of moles on each side of the equation, so adding up the coefficients. And the one that we just did is a little tricky because there are 2 moles on each side. So think about what that means in terms of shift. Is there a side of fewest moles? Is there a side with more moles? Think about how that might affect our changes.